Okay, 3.7 is hypothesis testing for the ratio of two population variances. So now you have two population and you have to test the hypothesis for the ratio of each variance. So you will have sigma square for variance. So step number 1, as usual, formulating your hypothesis. Now your hypothesis, you will have sigma 1 square sigma 2 square. So for the two-tailed test, it is equals and unequals. Two tails unequal. Right tail test greater than, left tail test less than. Okay, noted that sigma 1 square over sigma 2 square is equals to 1. Here. Okay, so we talk about the ratio. Alright, so step number 2 is your F test. F test is equals to S1 square over S2 square. Sample variance 1 divided by sample variance 2. For the ratio, the same as confidence interval, we will use F test. Okay, so for the decision on rejection region, so look at this one. Alright, so we have three cases, right? Hypothesis, two tail, one tail right and one tail left. So two tail, you will have two shaded region. Because of this one is skewed to the right, we will not have negative and positive. We will have different values here because it is not symmetrical. So if your case is two tail, you will have a two shaded region, right and left. How to find the value, the boundary value for the right hand side and the left hand side if two tail? For the right hand side, you will have F alpha over 2 because of two tail, and then nu1 nu2. Okay, so here you have S1 square over S2 square, right? So the position of the nu1 nu2 is here, nu1 and then nu2 for the right hand side. For the left hand side, you will have 1 over F alpha over 2 nu2 nu1. The position of the nu is changes here. Okay, tertukar, terbalik for the two tail case. For the right tail, you will have F alpha cannot be divided by 2 and then nu1 nu2 maintain the same. For the left tail, you will have 1 over F alpha nu2 nu1. So take note that one, okay? So let's look at the example. A manager in a large computer operation company wants to study the use of computer from two departments within the company. The departments are the human resource and the research department. So I will put human H as human resource, R for research. So I will use H and R here. Okay, is there any different? Okay, the keyword here is different. Different is not equal in the variability. When we talk about variability, we talk about variance or standard deviation of usage time for each job for the two different time at alpha 0.05. Okay, so step number 1, H null, H1. So here is different. So sigma H square not equals to sigma R square. I use H and R. I'm not using 1 and 2. So sigma square H equals to sigma square R. So this is your claim. Okay, for the step number 2. So this one, right? For the step number 2, it is S1. H square over SR square. So you have to put your data into the calculator and come up with this figure, S and the X. So the S here is 3.2711 square divided by 3.1464 square. You will get this 1.0808. Okay, now the important part is step number 3. Okay, step number 3, it is a two tail. Okay, refer back here, my notes here, two tail, you will have two shaded region. So here, panjangnya. Tengok sikit. Okay, this one on the right side, this one on the left side. So on the right side, it is F alpha over 2, nu 1, nu 2. So now our one is H, nu H, nu R. So here is 1 over F alpha over 2, nu 2, nu 1. So nu R, nu H. So see the difference here, right? So right hand side, left hand side. So right hand side, F alpha over 2. Alpha is 0.05 divided by 2, 0.025. Nu H. Nu H, human resource, and is equals to 1, 2, 3, 4, 5. So nu is 4. 5 minus 1. 4. Nu H is 4. Nu R is, nu for research is 6 minus 1 is 5. 5. So look at your stat table. Alpha 0.025, nu 1 4, nu 2 5. Nu 1 4, nu 2 5, you will get 6.3879. Okay, so you put here 7.3879. Okay. So for the left hand side, it is 1 over F 0.025, nu R, nu H. Nu R. Nu R is 5, nu H is 4. Okay, so 1 over alpha 0.025, nu 1 5, nu 2 4. You will get 9.3645. So 1 over 9.3645 is equals to 0.1068. So you put here 0.1068. Now you get the value boundary of the left hand side and the right hand side. Okay. The test statistic just now is 1.0808. So is it located at the rejection region or acceptance region? Okay, 1.0808 located here. 1.0808. So acceptance region. So because of that, you will have this one. Do not reject H null. So accept H null. Okay, so the difficulties part in here is this part. So be careful on the left hand side and the right hand side. Do more exercise. Okay, 3.9b. The director of the company has agreed to upgrade the computer processing time in the research department if the mean, okay, now we talk about mean processing time is greater than the mean processing time in the human resource. Okay, it will upgrade if mean is mu, research department is greater than mu human resource. Okay, this is the claim. Is there enough evidence to support the director's claim at 5% level of significance? So now the question asks you to test the difference between these two population mean. So now it is population mean. Why is it here in this variability? Because it's related to this equation. So now this is the hypothesis. So the hypothesis is mu research greater than mu human resource. So this one. Okay, so mu2 greater than mu1, it is H1. The same goes to here because I use mu research greater than mu H. Mu research less than mu H. Same here. Right, so for step number 2, which formula you want to use? Because in this question, they not mention assuming both population variance are equal or unequal. You don't know. How you want to get the information? So the information actually we can get from here, this one. Okay, so this one, our conclusion just now is accept H null. So this one. So equal or unequal? Equal. So now use equal. So that's why here we use equal formula for equal, because it's related to here. After you test this one, you accept that the population variance are equal. So because of the both population variance equal, you can use the assumption to this question, and then you can proceed, substitute into the formula, and then proceed with the 3.3.1 hypothesis testing between 2 mu. Okay, let's do exercise 3.7 number 1. Before service, a machine can pack 10 packets of sugar with variance weight of 35. So you will have before service and after service. Okay, can pack 10. So before can pack 10 with variance S square 64. After the weight, the variance weight for 5. For 5 packets of the sugar pack was 25. Do the service improve the packaging process of the machines? The keyword here is improve. So improve is okay. So if improve, it must be less than, because we talk about variability. Must be smaller value. Okay, because we compare the variance, we must take the smallest value. So if we want to improve the service, the variance must be smaller. So the H null and H1, so variance must be smaller. Okay, variance after must be smaller than variance before. Then the service will be improved. So here sigma square after greater than sigma square before. Step number 1. Step number 2 is the F test is equals to S1 square. So S after square over as before square. So I will use A for after, B for before. S square after is 64 over 25. So terbalik. 25 over 64 is equals to 0.3906. Okay, step number 3, one tail or two tail? To one tail, left or right? Left tail. Okay, left tail. So here is 1 over F alpha, no 2, no 1. So no 2 here is no B. No B, no A. No B is equals to no 10 minus 1 is 9. No after is 5 minus 1 is 4. No B is 9. No A is 4. Alpha is 0.05. So you find F 0.05, no B is 9, no A is 4. So look at your stat table, you will get 5.9988. So 1 over 5.9988 is equals to 0.1667. So put here 0.1667. Okay. So accept or reject 0.3906 located at 0.3 lagi besar daripada 0.1. So 0.3906 is here. So accept H null. So conclusion, you accept H null, right? So you accept H null, you discard this one, you accept H null. So you not support the claim. So you can write down at alpha 0.05 Okay. So actually the service do not improve the packaging processes. So number 2, a firm is conducting a study to compare two different physical arrangement of its assembly line. It has been determined that both arrangements yield approximately the same average number of finished units per day. The arrangement with the smaller variance in the number of finished units per day will be adopted as the new arrangement of its assembly line. So here, smaller variance will be adopted as its assembly line, adopted as the new. Okay, the result of two independent random samples are shown in the table below. Using alpha 0.01, do the data support the claim that assembly line will be adopted? So test this one. It will be adopted if the smaller variance. So sigma square line 1 is less than sigma square line 2, then it is adopted. If sigma square line 1 is less than sigma square line 2, we will adopt line 1 because line 1 variance line 1 is smaller than variance line 2. I will use this claim. Alright, and then the H null and H1. So sigma 1 square less than sigma 2 square, adopt line 1. So sigma 1 square greater than and equals to sigma 2 square is the alternative hypothesis. Step number 1. Okay, step number 2 is the F test. S1 square over S2 square. Okay, you have to find the S1 square and the S2 square. Put it into your calculator, this data, and come up with the S. So I give you the answer. The S1 square is 37.5219 square. This one is 61.0689 square. 0.3775. Okay, the rest of it you can proceed. So here I get this one is left tail. So because of the left tail, it is 1 over F alpha over 2 nu 2 nu 1. Say nu 2 nu 1. This one is nu 1, this one is nu 2. Nu 2 is equals to what? Nu 1 is equals to what? Okay, nu 2 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 14, 16, 18, 20, 22, 23, 24, 25 minus 1 is 24. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21 minus 1 is 20. So here is 1 over f 0.01 over 2. No 2 is 24. No 1 is 20. Okay, you can find. And then step number 4, it is accept H null. And step number 5 is do not support the claim. Okay, try. Let's exercise number 3. A company is planning to install a new machine to assemble its product. The company is considering 2 types of machine, machine A and machine B, but it will buy only one machine. The company will install machine B if the mean time taken to assemble a unit of the product is less than the mean time taken by machine A. The following table shows the time taken machine A and machine B. A. At 10% significant level, alpha 0.1, test the difference in variability. So we talk about variability, you have to test the sigma square machine A not equals to sigma square machine B. So test this one first. This is for A. So for B, which machine should be installed? For B, it's talk about the mean. The company will install machine B installed if mu machine B is less than mu machine A. So H null, H1 here is mu B minus mu A less than 0. Mu B minus mu A greater than 0. In order for you to proceed this hypothesis, you need to find this one first, the same to the example just now. So please try this exercise 3.7 and you can show me your answer. Thank you guys.